Hello everyone, today I will present the RTL87X2X Quick Start Guide, which aims to help users quickly get started and complete the project development. This is the main content of this PPT presentation, which will be covered in 4 parts. The first part is an overall introduction, providing everyone with a general concept of RTL87X2X. The second part introduces the hardware development environment. The third part is a tutorial on compilation and downloading. The fourth part involves hands-on practice with the EVB based on the above introduction. We'll now start with part 1, which introduces the development environment and the tools used for RTL87X2X. First, we need to have a general understanding of the RTL87X2X, which is a series that includes IC models such as C, D, E, H, and G. This PPT will guide users in quickly setting up the development environment for the RTL87X2X, including compiling the SDK, downloading firmware, upgrading firmware, and capturing logs. Users can download test files from the SDK to ensure that the EVB is functioning correctly. The RTL87X2X SDK supports both Windows and Linux systems. Users can compile the projects within the SDK using Kiel or GCC. Users can use the MP tool to download the files onto the EVB. Subsequently, the debug analyzer can be used to capture logs from the SoC end. During the development of the RTL87X2X SDK, users will need to use Real-Text Development Toolkit and the ARM or GCC Development Suite. You can refer to this table for specific details. Next, we'll introduce the hardware development environment. This section will cover the EVB through 4 key aspects. The EVB provides a hardware environment for user development, which is used for development and application debugging. It features 2 modes, download mode and normal mode, each requiring different wiring methods to set the correct mode. The image on the left shows the hardware setup for RTL87X2C, D, E, H, while the image on the right shows the hardware setup for RTL8762G. Users can refer to the EVB interface layout diagram to make the correct wiring connections. You can refer to these 2 diagrams to understand the module distribution of the EVB. The EVB has 2 modes, download mode and normal mode, and users need to use different wiring methods to set the correct mode. Since there are 2 types of EVBs, we will introduce them separately. Firstly, for the EVB applicable to C, D, E, H, to enter the download mode, you need to ground the log pin before powering on the EVB. Then you can download using the MP tool. By default, the log pin is P03. This process is necessary because the chip reads the level signal of the log pin upon power-up. If the level is low, it will bypass the flash memory and enter download mode. If the level is high, it will enter normal mode and run the application layer program. For the EVB to operate normally in normal mode, you need to disconnect the connection between the log pin and GND. This ensures that the log pin is not grounded, allowing the chip to detect a high level at the pin and subsequently enter the operating mode to run the application program. To put the RTL8762G EVB into download mode, there are 2 methods you can use. Method 1 is using the log pin. Connect the log pin to GND. By default, the log pin is P03. This is similar to the process described earlier. Method 2 is using the dip switches. The EVB is equipped with dip switches located on both the front and back sides. Set any one of these switches to the on position. This will ground the log pin, thus putting the EVB into download mode. Both methods effectively pull the log pin to ground. For the EVB to operate normally, you need to ensure that both dip switches on the front and back sides are set to the 1 position. This configuration will disconnect the log pin from GND, allowing the EVB to exit download mode and enter normal operation. By setting the switches to 1, the device is prepared to run its application program as intended. Now we move on to the third section, compilation and download. This table provides the downloading file descriptions for C, D, E, and H. The ROM patch image, BT stack patch image, secure bootloader image, and upper stack image are provided directly by Realtek. Users can download these materials through Anchor, the Realtek file release system. If you do not have an Anchor account, please request registration from an agent, PM, or FAE. Alternatively, you can directly download them from RealMCU. Additionally, the default downloading files are provided in the SDK directory, and users can directly use them. This table provides the downloading file descriptions for RTL8762G. In the previous documentation, some files can be directly generated using the MP tool. Here, we will introduce the steps to generate each of them. If no parameters need modification, users can directly load the default file from the SDK. You can refer to the illustrated steps to directly generate the flash map and OTA header file. Before downloading the file, users need to load the flashmap.ini file. The flashmap.ini is the generated flash layout, which can be understood as the address allocation of various parts in the flash. If the flash layout has been modified, users need to replace the original file with the newly generated flashmap.h. The OTA header file will also be updated accordingly. Please ensure the consistency between flashmap.ini and the OTA header file. Users can refer to the illustrated steps to generate the system config file. For first-time developers, it is recommended to keep the default configuration in the config setting interface. If the flash layout has been modified, the system config file needs to be regenerated. If no parameters need modification, users can directly use the default file from the SDK. All applications in the SDK can be compiled using either Keel or GCC. When using Keel for compilation, please note that different ICs require different versions of the compiler. You can refer to the instructions on page 6 for more details. As shown in the diagram, taking the BLE peripheral project as an example. Once the compilation is successful, an MD5 checksum bin file and a corresponding .trace file will be generated in the project's bin folder. The .trace file is used for parsing the SoC side logs. It is important to note that the MP tool uses MD5 as the checksum for the firmware file, and requires the MD5 value to be included in the file name suffix of the firmware to be downloaded. Therefore, the file that is downloaded is the app image with the MP prefix. Keel MDK is the complete software development environment for a range of ARM Cortex-M-based microcontroller devices. The toolchain version information for RTL8762G used by Realtek is shown as in the figure. To avoid compatibility issues between ROM executables and applications, it is recommended to use UVision version 5.36 or a later version. Configure the default compiler to ARM Clang version 6.17. The toolchain version information for C, D, E, H is shown as in the figure. To compile the GCC project, using the BLE peripheral project as an example, navigate to the GCC directory of the project and run the command prompt. enter the command ming32 make to initiate the build process. Once the GCC project is successfully compiled, a bin file with an MD5 checksum will be generated in the project's bin folder. Once the files are generated, you can use the MP tool to download them to the EVB. Double-click to run mptool.exe. Choose the appropriate IC type. The MP tool supports two downloading modes, MP mode and debug mode. MP mode is used during the manufacturing process. Debug mode is intended for developers during the development and debugging phases. The MP tool can download one or multiple files. If you are only downloading a single file, such as the Bank 0 app image, make sure not to select Erase All for download. To ensure that the EVB can be used properly, users can follow the aforementioned steps to perform a downloading test. Here is a concise overview of the steps. 1. Prepare the EVB and ensure that the EVB interface wiring is correct. Let the EVB enter download mode and then power it on. 2. Double-click to run mptool.exe. Refer to the illustration for detailed operating steps. Step A. At the load layout, load the flash_map.ini file. Step B. Click Browse to load all the downloading files. Step C. Click Detect to identify the COM port of the EVB. Step D. Click Open to open the COM port. Step E. Check Erase All for download. Click Download to start the downloading process. The progress bar shows the current downloading progress. Step F. The progress bar shows OK when the files are successfully downloaded. 3. After the files are downloaded, let the EVB enter normal mode. 4. Observe the behavior of the EVB. Users can verify it through a mobile app or check if the log on the SoC side meets the expectations. Users can also use J-Link to download the app image. Please ensure that other files have been downloaded using the MP tool. Follow the illustrated steps to proceed. System debugging with J-Link will be ineffective in DLPS mode. It is recommended that users disable DLPS mode when using J-Link for debugging. To use the J-Link debugger, users need to ensure that the SWDIO, pin 10, and SWDCLK, pin 11, pins are not repurposed in the program. Please refer to the illustrated information to select the appropriate cortex corresponding to the IC. In the J-Link debug interface, pay special attention to the area marked by the red box. Make sure not to select the wrong options in this section. Finally, after the files are successfully downloaded, we will verify whether the program runs as expected using the log and the mobile app. For the EVB of C, D, E, and H, you need to connect RX and log using a jumper cap to view the log. On the RTL8762G EVB, there is a dip switch on both the front and back. Both switches need to be set to the 1 position. Then, connect RX and log using a jumper cap. After the log connections are completed, the user can capture the SoC side logs using the debug analyzer to verify if the program is running correctly. Please follow the illustrated steps to load the relevant files, and then click Start to capture the logs. The .trace file is used to parse the binary log stream received via the serial port. A new .trace file is generated each time the project is compiled. It is important to ensure that the .trace file matches the code currently running on the SoC. If users encounter any issues during the development process, please provide the .log.bin.cfa files under the data file folder, as well as the corresponding .trace file. This will help Realtek analyze and locate the issue more effectively. Using the BLE peripheral project as an example, after powering on the EVB board, if see the log gap ADV start, it indicates that the device has started advertising. Clicking Connect in the Bluetooth app interface on the phone, and seeing the log message gap ADV stopped, because connection created, indicates that the phone has successfully connected to the device. The presentation concludes here. Thank you for your attention.